Welcome to The Explainer. Let's just dive right in. Today, we are breaking down the exact frameworks you need to evaluate enterprise AI agents and, more importantly, pass those high-stakes system design interviews. Whether you're building the next breakthrough assistant or sitting across the table from a rigorous engineering hiring manager, this is the exact blueprint you're going to need.
So picture this. Your AI agent got the right answer. Is it ready for production? Well, if you answer yes to this question during an interview, you've likely already failed. Because honestly, getting the right answer, that is just the absolute bare minimum.
Here is our roadmap for this explainer. We'll be looking beyond the right answer, avoiding the completion rate trap, evaluating the hidden process, grading benchmarks like GAIA and SWE-bench, handling real-world failures, and finally, designing the ultimate harness.
Section 1. Beyond the right answer, the 3 layers of agent evaluation.
We're going to start by looking at the iceberg of agent evaluation. You see, the correct final outcome is really just the tip of the iceberg floating above the water. A truly production-ready evaluation means you have to look at 3 distinct layers. Step 1 is the outcome. Did it actually do the job correctly? Step 2 is the trajectory. Did it take safe, efficient, and valid steps to get there, or was it just fumbling around blindly in the dark? And step 3 is operational. Did it meet your real-world latency, cost, and safety constraints? You literally need all 3 of these to survive out there in the wild.
Moving on to Section 2, the completion rate trap. Why 82% isn't always a pass. Okay, let's talk about the most common trap engineers fall into when discussing agent success. It's the task completion rate. Simply put, this is the percentage of tasks an AI successfully completes out of everything it attempted. And sure, this is absolutely the best headline metric to track. It's the one executives usually love the most, but stopping right here in an interview, that shows a massive lack of real-world production experience. Let's break down a real-world scenario to see why. Imagine an agent is handling 1,000 customer support tickets. An 82% correct completion rate looks pretty fantastic on paper, right? But if you break that down further, you might reveal a terrifying reality, a 3% unsafe or hallucinated response rate. Now, in an e-commerce chatbot, maybe that's just a quirky PR problem. But in finance or medicine, that 3% is a complete company-ending disaster. You absolutely must segment your completion rates to find those hidden dangers. Which brings us to Section 3, evaluating the hidden process. Why trajectory matters.
To catch those hidden risks we just talked about, we have to evaluate the agent's trajectory. Think of this as grading the AI's step-by-step scratchpad. The vital question you have to ask yourself is, did the agent reach the answer through a reliable, auditable, and safe process? We have to ensure the agent didn't just get lucky or rely on a deeply flawed hallucination that somehow stumbled backward into the right conclusion.
It's pretty easy to contrast the 2 extremes here. Good behavior looks like logically breaking a task down into valid steps, using precise tools, grounding answers in actual evidence, and knowing exactly when to escalate a risky case. On the flip side, incredibly bad behavior looks like jumping straight to an overconfident final answer, calling completely irrelevant tools, making unsupported claims, or just straight-up fabricating data.
So how exactly do we track this? Well, instead of storing raw, private chain-of-thought data, which, let's be honest, can be a messy privacy nightmare, senior engineers log specific structured traces for their production logs. You capture the user intent and plan, the tools selected with their inputs and outputs, the validation results and retry counts, the exact reasons for failure, and operational things like cost and latency. This lets you safely and efficiently debug the trajectory without wading through endless paragraphs of a robot's internal monologue.
Section 4. Benchmarks, GAIA and SWE-bench, grading the heavyweights.
First up is GAIA. This is a heavyweight benchmark for general AI assistants. It evaluates tasks requiring complex, multi-step reasoning, multimodal handling, web browsing, and tool use to produce an exact final answer. And let me tell you, GAIA is notoriously brutal. Why? Because its 450 tasks are conceptually pretty simple for humans. We score around 92% on it. Yet they completely expose massive flaws in an AI's planning and verification. In its original evaluation, GPT-4 with plugins scored a measly 15%.
But GAIA isn't perfect, and pointing out these specific blind spots during an interview proves you really understand the huge gap between academic benchmarks and enterprise reality. For one, GAIA doesn't represent workflows using private enterprise data. Plus, its exact answer scoring might totally penalize an agent that had 99% perfect reasoning but made a tiny formatting error. Public benchmarks also carry contamination risks, and crucially, GAIA completely ignores real-world production constraints like latency, privacy, and cost.
Now let's look at how this applies to the coding world with SWE-bench. SWE-bench is highly respected because it evaluates whether a coding agent can resolve real, messy GitHub issues. It's not just asking the AI to write a clean, isolated function. No, it requires the agent to read the issue, understand a whole repository, localize a bug, and generate a patch that actually passes the tests.
A crucial thing to remember is that static benchmarks degrade over time because AI models accidentally train on their answers. SWE-bench is constantly evolving to fight this contamination. As highlighted by OpenAI's 2026 analysis, we've moved from the human-filtered SWE-bench verified to SWE-bench live, which dynamically pulls in new issues to stop models from overfitting, all the way to SWE-bench Pro, which is designed to actively tackle harder tasks, data contamination, and unreliable testing. Knowing these versions shows you're right there on the bleeding edge.
Section 5. Handling real-world failures, taxonomies, and safety.
Even with the absolute best benchmarks, your agents are going to fail in the real world. Utilizing a structured failure taxonomy shows you can precisely diagnose where the pipeline broke down. When an agent fails, you can't just shrug and say, oh, it hallucinated. You need to know, was it an intent failure where it misunderstood the request? A retrieval failure with irrelevant documents? Did it format a tool or API call poorly? Or, most dangerously, was it a safety or escalation failure where it took an unauthorized action or plowed ahead when it really should have handed off to a human?
To properly track these failures, a mature engineering team has to use a dual approach. Offline evaluation uses fixed benchmark tasks before deployment. It's your safety net, perfect for regression testing, comparing models, and iterating on prompts. But online evaluation measures real, live production behavior. That is exactly where you catch real-world drift, monitor user satisfaction, and spot those rare safety incidents that a static test simply cannot predict.
And finally, Section 6, designing the ultimate harness, the senior-level architecture.
If you are ever asked in an interview or at your actual job to design a production evaluation harness, you're going to want to lay out these 5 core components. You need a dataset registry to store your tasks and risk categories, an agent runner to execute under controlled conditions, a strict tool sandbox to safely isolate code and database actions, a judge layer to rigorously score both the final outcome and the trajectory, and a metrics dashboard to track trends every time you tweak a prompt. Laying this out proves you can build a scalable, safe testing environment. These key design principles are your golden rules for isolating risk. You want to mix public benchmarks with private evals, sandbox your actions, and use human review for the ambiguous high-risk stuff. But crucially, you must track cost and latency specifically per successful task. Think about it. An agent that works super fast but fails 50% of the time is actually incredibly slow and expensive when you factor in retries and human cleanup. Always rerun your evals after a change and evaluate based on successful business outcomes.
I really want you to memorize this exact philosophy. As the quote goes, I would not rely on a single benchmark score. I would combine public benchmarks with private, production-specific evals. I would measure task completion rate, trajectory quality, tool correctness, safety, latency, cost, and escalation accuracy. Understanding that true agent reliability requires a massive multi-layered system is exactly what separates a novice from a senior engineer. So, as you head out to build these systems or tackle your next interview, I'll leave you with this provocative question. When your AI succeeds, is it actually reasoning through a reliable process, or did it just get lucky on the test? Thanks for joining me on this explainer, and keep building smart.